So yes, we just started a new chapter which was law of gases and dissolve. In that we discuss law of gases. We discuss these five law which like the basic introduction. So in today's video we're going to discuss the Boyle's law, the equation, not equation, but we just discussed that in this volume should be inversely to the pressure, and time or not time but the temperature and number of gas moles should be constant. So yes, today's video we are going to discuss more in a very deep. It would be Boyle's law. Boyle's law. So you need to watch that two videos first. I would suggest you, but let's get started with the Boyle's law. First thing, and I just write here in this you will see the volume. The volume of what? The volume of given mass you have. Given mass of gas. Because the mass we're talking here is about gas, because the chapter we are discussing is the gaseous state. So mass is inversely, which should be inversely proportional. I don't know how should I tab this to get this. Let me just write proportional to pressure at a constant temperature. So this was the basic. What does this mean? This mean, okay, so in this the volume of given mass, the mass you have, for suppose if it this body, then the mass it should be inversely proportional to pressure. It should be inversely proportional to what the pressure, and at what, when you have a constant temperature. So volume of given mass, this the mass, this should be the mass, okay, then this is inversely toward the pressure at a constant temperature. If you provide a pressure to this body, if here the molecules were this far, but in the second body you will notice a change. The change would be, the size would be same, I could not make it here, but when you provide pressure their particles will become this much close. So in this they wanna just say that the volume of given mass should always be inversely to pressure at what, when you have a constant temperature and number of moles. So yes, this was the basic. Now we are let's discuss what are the conditions. What are the conditions that means here? Uh, so you will find two conditions. First would be ideal, and second would be like gas, ideal and real. And ideal is a gas which is already present, not gas but the real gas, it is present in our environment. So in this we will also use. So the first condition says that the gas should be ideal. Should be ideal, okay. The gas should always be ideal. And what else? The temperature and number of moles of gas. Temperature, number of moles of gas should be constant, as I just told you. Constant here means there should be no change, because when you change temperature or number of moles there would be a change. But this law completely say if you will increase the volume, the pressure should always be decreased. If you decrease the volume, the pressure should always be increased. So these are not directly but inversely proportional. So the condition here says the gas you are taking must be an ideal gas, and you need to keep these both values constant. The values are temperature and the number of